everyone on page 15. Now it says here, solving identities, using identities to solve equations. We've already done these ones, solving equations. Right? We've done solving equations already. And when we say solving equations, it's the trig equations. But when we get into something like this, where it's a little bit challenging because not everything is in terms of cos of x, not everything is in terms of secant of x. So well, we'll see what happens. Okay, that's why it says here using trig identities. So what can we do so that we can write it in terms of just cosine? We can say that, hey, we know that it's going to be 3 cos of x plus 1 is equals to 2 times secant of x is 1 over cos of x. Right? This is an equation. We're not proving this, so that means we can cross multiply. We can move terms left or right on the left or right side of the equation. It's okay because this is an equation, we're solving it. So it's 1 over cos. Okay, well, what's that mean? What we're going to do is let's get rid of the cos in the denominator. How can we get rid of the cos in the denominator? You're going to either cross multiply, right? You're going to cross multiply there, or we can say I'm going to multiply by cos of x. We're going to multiply the cos of x. So if that's the case, okay, it's the same thing as cross multiplying, or you can say I'm going to multiply both sides by cos of x to cancel the denominator. So what happens here is I'm going to multiply this in within the left side, then we're going to end up with 3 cos squared of x plus cos of x equals 2. In this side, it cancels out, equals to 2. Is everybody okay with that piece? Okay. So now we are into something like this. Good. So it looks like everything is in terms of cos of x, and we're also having this quadratic trig equation. So how can we do that? We're going to leave one side of the equation 0, so we're going to move the 2 to the other side, so that becomes 3 cos squared of x plus cos of x minus 2 equals to 0. Now how do we do this? Now we have to do factoring. Okay. Now, if you're comfortable with factoring this right away, go ahead and factor that. But what we can do is we can say let n equals to cos of x. Okay, because sometimes this is helpful with factoring. We don't have to worry about the cos of x. We can just let n be cos of x. So what happens here is it's going to be 3n squared plus n minus 2 equals to 0. So it kind of looks like, boils down to a trinomial. And then that's easy to factor, right? A factoring trinomial. So how do we factor this trinomial? The only way you can get 3 is you go 3 and 1. So 3n times 1n. I'm going to have the here, or 2 factors in here that would add up to 1 in the middle. So that becomes, I'm going to go plus 1 in here and then minus 2 there. Is everybody okay with that? Because if I multiply this outside I'm going to get 3n. Inside I'm going to get negative 2n. So that adds up to 1n. Okay. So the factored form is 3n minus 2 times 1n, or n plus 1. Now we can put back the cos of x. So we can put back, so it's going to be 3 cos of x minus 2 times cos of x plus 1 equals to 0. Now that we have this, we have to solve for x. Okay, so we have two possibilities in here. We have 3 cos of x minus 2 equals to 0. Oh, you can't see that, sorry. Solve for x, so that becomes cos of x equals to 2/3. And now we have to ask ourselves, okay, where is cos positive? 2/3. Cos is positive in quadrants 1 and 4, right? So there's going to be a solution here and here. Solutions there and there. And I have to be mindful of my domain. It's from 0 to 2 pi, right? So what are the two solutions? There's only two solutions here. So in quadrant 1 and quadrant 4. So let's figure out the x. Gotta make sure my angle is in radians, right? So cos inverse of 2/3 is 0.84 radians. Okay, so that's the answer in quadrant 1, but that's also the reference angle. So that's the answer in quadrant 1. What's the answer for quadrant 4? Or it's going to be 2 pi minus 0.84. Okay, 2 pi minus 0.84. It's going to be 5.4 radians. 44 radians. So if you do 2 decimal places, 5.44 radians. Is that okay with that piece? Yeah. Now, what's the other one? Cosine of x plus 1 equals to 0. So the other possibility is cos of x plus 1 equals 0. So that means cos of x equals to -1. Okay. Well, that's a special angle in here. So where is cos a -1? It's going to be at pi. Okay. That's the only answer that we have that fits within our domain, right? So just the pi. So therefore, how many solutions do we have? We have 1 for quadrant 1, 1 from quadrant 4, and 1 right there at pi. Okay, so therefore, x equal to 0.84 radians, 5.44 radians, and pi radians. You can put r radians if you want. So 3 different solutions there.
You don't have to put the radian.
No, we don't have to. It's understood it's radians because it's already pi. Okay?
You don't have to write it in general formula or no?
Oh no. If the question says solve each equation, then yeah, you would have to continue on with the general solution, but then they say over the domain, this domain. So we're only taking this piece of the graph, right? From 0 to 2 pi. That's kind of nice because it limits our possible solution, right? Instead of like infinitely many possible solutions. Okay, that was pretty good, right? That's something that we've done before, we've seen before. Now this one, let's see. Oh, what can we do here? Oh, okay, so we already have one possible solution, right? Because this one here I got in terms of cos of x, and this one in terms of sine. Okay, so if we were to use our identity, we can say we know that cos, I'll write down the identity here for the sake of the people who weren't here. So identity, we know that cos squared theta, okay, I'll use x because it says x. Cos squared x is equals to 1 minus sine squared of x, right? So instead of cos squared of x, I'm going to write it all in terms of sine of x. So let's do that. So it's 2. I'm going to replace that with 1 minus sine squared of x minus 3 sine of x equals to 0. Okay. Now the next logical thing to do is to expand this. This becomes 2 minus 2 sine squared of x minus 3 sine x equals to 0. Okay. What's the other logical thing to do?
Straighten it out.
Huh?
Organize it.
We can organize it, or we can say we're going to multiply everything by -1 on both sides. Okay. Before I even start factoring this, I want to start with the leading coefficient of +1. Right? So I can multiply this by -1 and multiply the left side with the -1 and the right side with the -1. So I'm going to end up with 2 sine squared x plus 3 sine of x minus 2 equals to 0. So that simplifies things a little bit. The leading coefficient is positive. Okay. Now, if you're comfortable to factor it from this stage, you can go ahead. If what we can do is we can say let n equals to sine of x. Okay, to kind of simplify it. So it becomes 2n squared plus 3n minus 2 equals to 0. See if we can factor this out quickly. 2n squared, that becomes 2n times n. And then I'm going to end up with a positive 3 in the middle and -2 at the end. So that's going to give us plus 2 and -1. So 2n minus 1 times n plus 2. Is everybody comfortable with this factoring? 2n squared plus n plus 2. Yeah? Now let's put back the sine of x. So it's going to be 2 sine of x minus 1 times sine of x plus 2 equals to 0. Okay, so we have two possibilities in here. We have possible solution in this factor, and then we'll see what this solution is. Okay? So for this part, 2 sine of x minus 1 equals to 0. So that means sine of x is equals to 1/2. And I gotta ask myself, where is sine of x 1/2? Where is sine of x 1/2? So it's gonna be pi by 6 here, and 5 by 6 on quadrant 2, right? So pi by 6 here in quadrant 1, and 5 pi by 6 in quadrant 2. So x is equals to pi by 6 in quadrant 1, or if it's 5 pi by 6 in quadrant 2. You okay so far? Now let's take a look at this piece. Gotta go sine of x equal plus 2 equals 0. So sine of x equals to negative 2. Where is sine of x equal to negative 2? Okay, now see here, sine of x is 2 over 1. So the opposite side is 2, hypotenuse is 1. Not possible, right? So that means there's here, x, no solution. Okay, so therefore, we're going to write down our solution. So therefore, the solutions are x equals to pi by 6 or 5 pi by 6. And that's it. Those are the only two. Any questions here? What did we do? Okay, we tried to writing this co-squared or this equation in terms of just one trig function, right? We wrote it in terms of sine, and that makes it a lot easier to solve. Yeah.
I had trouble with factoring the 2n minus 1 and plus 2.
Oh, this one? Yeah, this piece? Okay.
So I just want 2n squared minus 1 plus 4n
That's okay.
minus 2
Yeah.
in terms of sign.
So you basically, this is what you did. So up to this particular point, this is what you did. 2n squared plus 3n minus 2 equals to 0. And then you look at, okay, 2n squared, factor of negative 4, that adds up to 3, so that becomes positive 4n minus n minus 2.
Yeah.
Yeah? And then you did factor by grouping.
Yeah.
So 2n, this is going to be n plus 2, and this is a negative 1, n plus 2, and then your n plus 2, n plus 2, 2n minus 1. Yeah, it's okay.
Is that still efficient? Like,
Oh,
otherwise?
yeah, that works really well. It's just that for me, I see it this way already.
I don't see them yet. I did wrong.
You had to go through the process, and that's okay. So these ones here, I skipped from here to here. I skipped some steps. How many steps did I skip? 2, right? That's okay.
Okay.
Yeah. Yeah,
Well,
you're not doing anything wrong by doing that.
Yeah, it's just, is that as efficient?
Allowed?
Or,
I think just at some point, the more that you've done factoring, you can just easily go from here to here.
okay.
But this is perfectly fine.
Okay.
Good? Was that the only one?
Yeah.
Any other ones? No? Let's take a look at letter C. Let's see what could I possibly do so that I can solve this equation?
And is it the same?
Yeah, write it in terms of sine. Yeah, so let's go ahead and do the same, just like what you said. Okay, so in terms of sine, cosecant is 1 over sine of x. And what we're going to do is get rid of the denominator in here. So the denominator is sine of x. So multiply each side of the equation by sine of x. sine of x. Okay. So if I multiply that in, that becomes 2 sine squared of x equals 2. I gotta be careful in here. On the right side, I have a binomial that I need to multiply it in. Okay, so it's going to be 3 times sine of x. So 3 sine of x. And it's going to be sine of x. We'll cancel this sine of x. We're just going to have 2. Okay. So that becomes 2 sine squared of x minus 3 sine of x minus 2 equals to 0. So from here, from these 3 steps that I've written down so far, does that make sense to you? Where did I get the 2? So if I multiply, I want to get rid of the sine of x in the denominator, so I had to multiply both sides by sine of x. So if I have this, okay, I'm going to cover this piece. 2 times 1 times sine of x over sine of x. Let me write that down. Okay, so 2 times 1 over sine of x times sine of x. So the sine of x cancels each other out. And then you're left with just 2 times 1, which is 2. Okay. So from here, let's see. If you want, we're going to say let n equals 2 sine of x. It's going to be 2n squared minus 3n minus 2. Did you factor it without?
I put the n in, but I didn't do it your way. No,
Okay.
not yet.
So this is what I'm thinking about, okay? I have 2n squared. The only way you can break it up into factors is you have 2n and an n. That's it, right? There's no other way. Or you can go n, 2n, but that's just 2n and n.
Put it a 3n?
To get this one,
Oh, okay.
right? The only way I can get 2n squared if I have 2n times 2n squared. Now I look at this one here. How can I get negative 2? Well, the only way I can get a negative 2 is if I put negative 2 here and a positive 1, right? Would this work for me?
Yeah.
Let's see here. 2n squared. This is going to be,
Goes to 2.
that's going to be 2n. And this is going to be minus 2n. That's not going to work. Would that work? I'm going to get 2n squared.
Other way.
It's 2n squared. And I'm going to get 2n minus 2n. Well, that makes it 0 in the middle. Right? So what can I do? What I could do is I could put plus 1 in here and minus 2 over here. So 2n times n, still 2n squared. 1 times negative 2, that's still this part. What makes the middle is these times. Would that give us negative 3n? This is going to give us negative 4, positive 1, that's negative 3, negative 3n.
It's a lot of trust there. I need to see it.
Or, here's what it says, what it looks like.
I see it. It's just, for me, if I were to do something like that, I wouldn't trust that I got
As-
there. I'd need to look at my work to make sure I got there.
Yeah, like this one is not as bad because if this one becomes 6n squared. There's many possibilities. I could put 6 times 1, 3 times 2, or 2 times 3, and then if this is like 24. Yeah, that's going to be more possibilities. Okay. So is everybody okay with this piece? Okay, good. I'm going to clean it up a bit so it's not messy. Okay, now we got two factors here. I'm going to put back the sine of x. So 2 sine of x plus 1 times sine of x minus 2 equals to 0. So I have this piece. 2 sine of x plus 1 equals to 0. So sine of x equals to negative a half. And I gotta ask myself, where is sine of x negative a half? Where is sine of x negative a half? Negative a half. That would be in quadrant. Sine would be the y, so that's going to be 3 and 4. 3 and 4. Okay. So this is negative 1/2. So that becomes 7 pi by 6. And this is going to be 11 pi by 6. You okay with that piece from here to here? These are the two solutions for this factor. Well, what about this factor?
No solution.
Sine of x equals to 2x, no solution. So therefore, our only solutions are and then the other 7 pi by 6, and the other one is 11 pi by 6. Yeah? Good. Okay. Last example. And this one here, this one's a little bit weird because when you look at that, okay, I got sine of x and then root 3 cos of x. How did I do this? Now sine of x, if only it has like some square somewhere, right? Like we could totally change it in terms of one to the other, but we don't have that. And I see sine and cos, okay? So this is what I did, okay? A reciprocal? Okay. Then it would be reciprocal of this would be cosecant. No, it would still not work, right? So here's what I did this. So you're gonna be, okay, what am I gonna do? I'm gonna,
Can you square the square root 3 cos? Or you can't?
no, I can't, because if I do it on this side, I gotta do it on this side, and I can't just square part of it, I gotta square the whole thing.
No, I mean, if you squared all of it, would it be sine or would it be sine times cos?
Okay, that's an interesting, so let's say if I square this, okay. Sine of x plus root of 3 cos of x equals to 0. Okay, so let's say if I squared this and I squared this to somehow create a sine square and cos square, then I'm going to get sine of x plus root 3 cos of x, sine of x plus root 3 cos of x. I'm gonna get this,
And then
and
two square root cos,
Then we have like that break and
or
then.
would it be 6?
now the middle term would be
Sine or cos?
root of 2 root 3
Two
sine x cos of x, so that's still a mix. Yeah. Yeah, this is an interesting one. Any other thoughts?
They always have to be the same function?
Doesn't have, this one might not have to be the same function. You mean the same in terms of sine or cos? Sometimes it's helpful, sometimes it's not helpful. Okay, in this case,
You just separate them, like sin x equals to 0 and root of 2 cos of x equals to 0.
they have to be factor. Yeah, it's called the zero product property.
Multiply each term by a 1.
Okay, this was my strategy for this one, okay? Okay, so what I'm gonna do is I'm gonna put this over there, because technically I can't make one or the other. Okay, so I can go root of 3 cos of x equals to sine of x. And if that's the case, what I'm going to do is I'm going to divide by cos of x on each side. So I got cos of x is there. And I got root of 3 over here, which is sine of x over cos of x. That's tan of x. Now I got to ask myself, where is tan of x root of 3? Where's tan of x root of 3? Okay. So this is going to be root 3 over 2, or 1/2, or 1/2 root 3 over 2. Where's the tangent going to be root of 3?
No, right here.
Larger.
Here.
It's going to be here, right? Because it's cos or sine over cos.
When we brought sin x the other side, then it's supposed to be negative.
Oh, yes, it is. Yeah, it's negative. Yeah, should be negative right there. Right there. So it's going to be negative root 3 is equals to tan of x. Where is tan negative? Quadrant 1, I'm sorry, quadrant 2, quadrant 4. But where is it negative root of 3? Negative 1/2 root 3 over 2, or
2.
1/2 negative root 3 over 2. So where's 10 negative 3? That's going to be right here.
Because it's y over x.
Yeah, it's y over x.
So we need a
So it's going to be x is equals to 2 pi over 3. And then the other one is over here. It's going to give us 5 pi over 3.
Which one's that?
So this one and this one. I just wrote down the 30 and then the 60 so that I can figure out which one is going to give me the negative root of 3. So it's right here and the other one's right there. Okay. Is that good? So we've used our knowledge of trig identities to help us kind of solve for an equation. What we're trying to do is we're trying to just make it one trig in terms of either sine or cos or tangent. Okay, so therefore these are the two solutions that we have. Good. How do you feel about that one? Okay. So, lots and lots of work for us to do. I hope you're keeping up with the homework. You can try these questions in here. This is your mini assignment on top. There's so many assignments, right? You feel like you're getting bombarded with assignments after assignments after assignments?
Not by you, every other class.
The other assignment, hopefully it's going well for you. Okay, you have 2 weeks to work on that one. This is like a mini assignment. So this is proving, verify, non-permissible value. Proving, verify, non-permissible value. I'll give this to you now.
That's a hand.
You can, yeah, this is a hand in because it has a marks attached to it. Okay. So for the remaining of time, we have about 15 minutes or so. You can either work on this piece, you can either work on your major hand-in assignment, or you get to work on this page.